Hello, let's see serverless architecture in today's class. I can explain the serverless architecture in 10 minutes. We'll see first what is serverless architecture, how it works, what are the benefits that you can get using serverless architecture, typical use cases related to serverless architecture, where you should have to use serverless architecture and where you should not use serverless architecture, all in this 10 minutes video. Let's start with what is it. It's a type of architecture which is considered as an alternative to traditional on-premises server-based architecture. Serverless architecture is a cloud computing model where you can build and run application without managing the servers. That is, the cloud service provider automatically handles the infrastructure tasks like server provisioning, scaling the server, patching the server wherever required, and maintaining the servers. Basically, serverless is nothing but you write the code and host it in the cloud or make the cloud to run it. That is, you focus only on building the business logic, design the application, while platforms like Microsoft Azure, Amazon Web Services, or Google Cloud can handle everything else. It is also called as a cloud server architecture model. In serverless architecture, no server management. That is, you need not maintain any servers locally. That is, in the on-premises infrastructure. Your application will be using cloud servers or cloud services. Auto scaling. Handles 1 to millions of requests. It helps for both horizontal as well as vertical scaling based upon the application requirement. It saves cost for you, that is, pay as you go model. There is no ideal cost associated. You need not require upfront investment cost. You can release a server or resources when it is not required. So these are all the some important point related to serverless architecture. Now let's see the traditional architecture that's being followed at on-premises versus the serverless architecture. You could see two different diagrams here. The one at the top is an example of a traditional on-premises architecture where we have a web server which connects to a DNS server which routes the traffic to load balancer which again decide to route the traffic to either a static content that via CDN or to any of the web server available, which in turn interact with application server and which can connect to database server for a specific task for completion. So this is a traditional on-premises architecture. So it has many servers which are all lying on the on-premises. And that's what illustrated here in this diagram. And now let's see what is the equivalent of this in serverless architecture. When you design a serverless architecture, you should have to go for any of the cloud service provider like Amazon Web Services, Microsoft Azure, or Google Cloud. Whatever you are seeing here is specific to Microsoft Azure. You have web browser which connects to any of the services illustrated here. To start with, the equivalent for the DNS server is Azure DNS service, which in turn connect to Azure CDN that will decide about the traffic to either the static content or the dynamic one. And the dynamic one will hit Azure application gateway. There are other options also available, which in turn connects to Azure VM or Azure App Service or Azure Kubernetes Service to perform any application specific logic, which in turn consume any of the database services hosted by Microsoft Azure. It may be Azure SQL DB or Azure Cosmos DB. This is how the um, on-premises architecture, whatever you see here, can be mapped with a serverless architecture. Now, let's see the real mapping between the traditional architecture and the serverless equivalent. If you see here on the left, the traditional architecture component are all put up here. What is equivalent services available in terms of Azure is put up here. And this might helpful for you to decide about what are the services that you should have to choose while designing your application. Now, let's see the advantages of going for serverless architecture. The first one is about quick development. Here, you need not worry about setting up servers and you can focus on designing your application, code, testing, and ready for deploying it into the cloud infrastructure. That is the first major advantage of going for serverless architecture. The second one is it is cost efficient. You can acquire a resource when required and release them if you do not require any more. Third important advantage is it is available for you 24 by 7 all 365 days. So these are some of the advantages of going for serverless architecture. Let's see some of the use cases associated with the serverless architecture. The first one is about REST APIs. You can have an API gateway with Azure function. For example, you can use Azure API management with Azure function to expose REST endpoints. Here, API requests trigger functions that to process business logic and return the response without managing any servers. Second one is real-time file processing. You can use Azure Blob Storage events to trigger Azure functions when the files are uploaded. For example, Azure function process files. Say let's take resizing images or parsing large data and instantly store the result or send a notification where you can go for serverless architecture. Third one, chatbots and AI integrations. You can go for Azure bot service with Azure function to handle user interactions. You can integrate Azure OpenAI service or cognitive services for intelligent responses. Fourth one, IoT event processing. You can use Azure IoT Hub to ingest device data and trigger Azure functions. You can process telemetry in real time and route it to storage, perform analytics, or alert any system. The last one is related to cron-like task, that is scheduled task. You can use a timer to trigger Azure function to run jobs on a particular schedule. This is ideal for batch processing, cleanup task, or periodic data sync without dedicated servers. Now, let's see when you need to go for serverless architecture. You can go for serverless architecture if you have a scenario like event driven workload. Say, for example, application react on events like file upload, messages, or HTTP trigger using Azure function. It's ideal with services like Azure Event Grid or Service Bus for real time processing, in which serverless architecture is a right choice. Second one, if you are having unpredictable traffic, that is, serverless architecture helps in auto scaling instantly based on the demand. and it handle sudden spikes without manual interventions. Third one, if you are designing a microservices architecture, you can run it as an independent function, enabling loose coupling and faster deployments. Third one, if you're looking for rapid prototyping, that is, develop and deploy quickly anything without worrying about the infrastructure setup or scaling, then you can go for serverless architecture. Most important step, you should not go for serverless architecture if you are in any of these three scenarios. If you are having a long running processes, for example, video rendering or large batch data processing, that is converting a 2-hour 4K video, don't go for serverless architecture. You can go for on-premises VM servers to handle such jobs. Second one, high performance, low latency systems. For example, high frequency trading platforms or real time gaming engines, you should not go for serverless architecture. These require ultra low latency, that is, milliseconds or microseconds. But serverless can introduce cold start delays, making it unsuitable compared to dedicated infrastructure. And the last one, applications needing full OS control. For example, legacy mainframe like applications or software requiring custom drivers. Serverless platform don't allow OS level access. So these are the areas where we need to be careful on recommending serverless architecture for any problem area. With that, I end up today's session, and I can come with more example for the serverless architecture in coming session. With that, thank you very much. Bye.